Welcome back, learners. So now moving on to the last concept of this lesson, that's now looking at the refraction of light in more detail. So the refraction of light. When light travels from one medium to another, it bends. So if light moves from one medium to another medium, it is going to bend. Now this bending of light is called refraction. So the bending of light is referred to as refraction. So this light can either bend or change direction. And that bending of light or the changing of direction is called refraction. So when light enters a different medium at right angles, it does not change direction. So if this is now the border between two mediums, that now being air, let's assume it's air, and maybe water. If light enters, if light travels from one medium to another medium at 90 degrees to each other, then there is not going to be any change of direction. It is going to be now moving still in the straight line because it is entering at right angles. Remember, right angles meaning that it is perpendicular or it is at 90 degrees, as we can see by that notation given there. So when light enters a different medium at a right angle, it does not change the direction. So light behaves as a wave, this we know. Light behaves as a wave, and waves travel at different speeds in different media. So if light is moving from one medium to the other medium, the speed of that light is going to change. It can either increase or it can decrease depending on which medium it is moving from and which medium it is moving to. For example, light travels faster in air than it does in water. So if light is moving from air into water, in air we know that light travels faster. Once it enters the water now, the speed of that light is going to slow down. It's going to be much more slower than it was when it was traveling through air. So when light enters a different medium, it changes speed, as we have said. When it is moving from air to water, the speed of that light is going to be changing. Now, if it entered at an angle other than the 90 degrees, remember we said if it enters at 90 degrees, the direction doesn't change. However, if it enters at any other angle but other than the 90 degrees, then the direction, it is also going to change. So we're saying that the more dense the medium, the slower the light moves. We know that air is less denser than water. So in air, speed is going to travel faster than in water because water is much more denser than air. So in water, the light is going to be much slower as compared to in air because the water is more dense. What we are saying is, if light moves from a less dense medium like air into a denser medium like glass, so moving from air to glass. If light moves from a less dense medium like air into a denser medium like glass, then the light slows down, as we have said. Less dense to more dense, light slows down. But from more dense to less dense, the light is going to increase in terms of the speed. So we are also saying that not only will it slow down, the light will also change direction. And by that, in this case, the light will bend towards the normal. So from less dense to more dense, the light is going to slow down. And if it slows down, it goes towards the normal. Remember the normal line, it is the imaginary line that is drawn perpendicular to the surface. Now that imaginary line helps us to measure the two angles that we can either have, the angle of incidence and in this case, the angle of refraction. So when light is moving from air to glass, it is going to slow down and is going to bend towards the normal. Very important to note. And then the opposite is true, that if light is moving from a more dense medium to a less dense medium, it is going to increase in speed, is going to be faster, and the light is going to bend away from the normal, because from less to more, it's towards, but from more to less, it is going to be away. So in summary, what we're saying is, if light moves from a more dense medium to a less dense medium, then the speed of the light is going to speed up and move away from the normal. As we can see, or from less dense to more dense, the light changed direction and moved and bent towards the normal. However, from more dense to less dense, the light changed direction as it entered the other medium, and the light bent away from the normal. As you can see, this is your normal, and your light bent away from the normal. So from less to more towards the normal, from more to less away from the normal. We always need to keep that in mind. Furthermore, when light refracts, remember refraction is the bending of light. When light refracts and changes direction as it passes through different mediums, it can also distort what we see. It can distort so what we see may not be actually what we are actually seeing or what we are looking at. So refraction can be used to explain why images appear to be distorted when we view them through transparent mediums. For an example, if you're looking at your legs or hands through some water, they will appear closer than they actually are. Why this is because the light is going to be refracted. Remember, when you are looking at we can be looking at our legs or hands through, in this case, water. They are going to be appearing as if they are closer than what they actually are. Why does that happen? Because light, it is bending. Remember, light moving from a less dense being air to a more dense medium, that is being water. That is going to be from less dense to more dense, the light, it is going to bend towards the normal. And when that happens, the object that you are looking at will appear closer than what it actually is. However, if it is moving from a more dense to a less dense medium, the object will appear even further than what it actually is, or how actually it is. Now, in terms of the colors then, we know when white light enters the prism, we know that white light consists of the 7 different colors, the visible spectrum. So when that white light enters the prism, it is going to be refracted. Remember, refraction, that's now the bending of light. And when this happens, it is going to produce the 7 different colors that we are seeing here. So the different colors of light travel at different speeds in the prism, so they are refracted at different angles. So when light enters this prism, all of these colors that we are seeing, they are going to be traveling at different speeds as they are passing through the prism. And because of that, they are also going to be refracted at different angles, and they are going to split into 7 different colors, as we can see. They are going to split into 7 different colors, starting from the red, going all the way to the violet, and those ones we do know that they are making up the 7 spectrum of light. So prisms are not the only objects that can split white light into separate colors. Remember, regardless of what object splits the light, that light will always split into these 7 different colors. We can use a different object to split the light. However, they will always split into these 7 different colors. So the examples would be, we can also think of the raindrops. So light from the sun enters the raindrops and refracts. Remember, refraction, that's now the bending of light. The light is then reflected off the back of the raindrops, and then when that happens, it is going to keep on being reflected. So if we're saying that the light from the sun enters the raindrops and is going to be refracted, or it is going to refract, remember, it changes speeds and changes direction as well. The light is then reflected off the back of the raindrop, and when the light passes out of the raindrop, it is refracted again, and the colors split up even more. Remember, when the light is refracted off one raindrop, it is going to split into 7 different colors. Now it is going to pass through another raindrop, and then it's going to split even more into 7 different colors again. The 7 different colors are still going to be the ones that we have talked about, the Roig beave. So the white light will always split into these 7 different colors. And if this continuously happens over and over again, we then going to see the rainbow that we're seeing after a light rain, and then the sunlight that comes after that rain. So how does this happen? When we see a rainbow, we see a combination of millions of raindrops. Although each raindrop refracts and reflects all 7 colors, we only see only color of light that is being reflected from each particular raindrop. So what we are seeing, that those are light rays coming from the sun are going to be refracted and reflected over and over and over again. However, what you're going to be seeing, it's just going to be the 7 different colors, not the millions and millions of 7 different groups of colors that are going to be reflected and refracted from those millions and millions of raindrops. We're just going to be seeing the 7 different colors. So this depends on the angle of the raindrop from our position. So what we are saying here is this. The raindrop higher up the sky reflects the red light to us, and the raindrop lower down is going to reflect the violet. Remember, it starts from red. We are starting from red all the way to violet. So the raindrop at the highest point will reflect the red, and the raindrop at the lowest point is going to be reflecting the violet. And all the other raindrops in between will be reflecting all the other colors. And what you're going to be seeing now will be now the combination of all these different colors making up the 7 different colors of the spectrum. So now, all of those can now be drawn in a ray diagram, and we do know that a ray diagram is a diagram that shows the path of light. We know that light rays are drawn using straight lines. They need to also have the arrowheads. In this case, because light is being refracted, it can either bend towards the normal or bend away from the normal. So the examples that we are seeing here, they are showing light moving from one medium to the other, either moving from a less dense medium to a more dense medium, and also moving from a more dense medium to a less dense medium. This shows you exactly what happens when light moves from a less dense to a more dense. We know that it bends towards the normal. If the light moves from a more dense to a less dense, it bends away from the normal. So with that said, I hope you had as much fun as I did learning about the refraction of light. Remember, the refraction of light is the bending of light. When light enters a medium at any angle other than the 90 degrees, it is going to change direction, and if it changes direction, it can either be moving towards the normal, or it can also be moving away from the normal, depending on the types of mediums that we are having. So with that said, I hope I see you next time. Bye.